Okay, so moving on. We're into section 1.5. I believe there's a total of 6 sections to this chapter, so we're getting close. You will have a quiz over 1.3 and 1.4, and don't be surprised if I'll ever sprinkle in an old problem, but you kind of got to know the old stuff to do the new stuff anyways. So infinite limits, I've gone and upgraded the markers, so hopefully these will show up better. All right, and it says one-sided limits continued. So the first thing I want you to understand is that when we do a one-sided limit, it's not necessarily a true limit. It's just asking only from that side, what are we approaching? So the best thing to do is just get started, and we're going to look at, so these are still one-sided limits, and we're going to still look at these numerically, graphically, and analytically. And your classmates here already said that, so they knew what was coming. So we'll get started with example 1, and we'll take the function 1 over x minus 3. That's the function we're going to work with. And for right now, we are going to look at the limit as x approaches 3 from the right of 1 over x minus 3. That's what we're going to look at. Okay. And there is an answer that we have to give. On a one-sided limit, so this is, so first of all, how do I know this is a one-sided limit? The plus. Yeah. We're going to approach 3 from the right. All we're doing is tell what the y's go to. What's the trend for the y's? So as x values approach x equals 3 from the right, what do the y's approach? Only from that side. So in this case, since it's not a true limit, since we're not going from both sides, I don't have to approach a specific y. That's an important bit of information. Now, what's the cheating I always like to try? How do I like to cheat with limits? Direct substitution. But if I do direct substitution, I get 1 over what? So 1 over 0 is not 0 over 0. 0 over 0 usually tells us there's a what? A hole. 1 over 0 typically is going to tell us that there's a vertical asymptote. So what's happening is there's probably a vertical asymptote at 3, and we're going to, most of the time mathematically, that's what we're going to have. So here's how we're going to work this. We're going to work this all 3 ways. We're going to start with a table. So what I'd like you to do is go into y1, put your 1 over x minus 3. Make sure that all of x minus 3 is in parentheses, and go to your table. And let's just approach 3. So 3.1, 3.01, 3.001, 3.0001, 3.00001. And we'll give the outputs for those. And then we'll look at the trend that way. So we're gonna solve this all 3 ways. Numerically, we're gonna use a graph, graphically, and then I'm going to show you how I would do it by hand, analytically. So, how can you possibly figure this out by hand? Well, I'll show you. Okay. It's kind of cheap, but I think it works. And the key thing is to think about what happens to this fraction. Okay? Because if you can think numerically what's happening to the fraction, it's going to help us analytically. Okay, so, I can do these. I think I can do them in my head. The first number you should have got was what? 10? Should have got 10. If not gotten 10, you've done something wrong. Then you should have got what? 100. Then you should get what? 1,000. Then what? 10,000. Well, now it's not rocket science. We can see what's happening. 100,000. So the question is, what's the trend? As we approach 3 from the right, what are the y's going to? Infinity. That's exactly right. And that's the answer you give. Because it's a one-sided limit, and we don't have to give a specific y, we're just saying what are the y's going towards. That's it. So your answer on this is infinity. So I'm going to show you what are the 3 ways I could work this limit and know that it's infinity. But let's first talk about why this is happening. What is the denominator? What is the denominator going towards? Not the fraction. We see the fraction, we see the answers. What's happening to the denominator? It's getting closer and closer to what? 0. It's getting closer to 0, right? Because I'm approaching 3. The closer I get to 3, the closer the denominator gets to 0. Thus, the closer I am to 0, what happens to my fraction? It becomes what? Look, when I'm talking about the fraction is what's giving me these answers. When I'm talking about the denominator, I'm talking about what happens when I plug this into the denominator. You understand the difference? So it's important to understand why when I have a fraction, the bottom is becoming this, thus the fraction is becoming this. So if you can fill in the blanks. The denominator is becoming this, thus the fraction is approaching this. What is the denominator becoming? Smaller and smaller, closer to 0. Because when I plug in this, 3.00001 minus 3, I get 0.00001. The denominator is becoming smaller and smaller, closer and closer to 0. But then what's happening for my answer? 1 over a very small number, you reciprocate and you get a big number. That's why our answer is becoming large. Okay, so I want you to kind of understand what's happening numerically there. That's why that's happening. Okay? Thus the answer is infinity. So can you read the table and see? So if we increase or decrease without bounds, we go to infinity or negative infinity. Now the graph. So we studied this type of function in pre-calc, a rational function, and I can see that the vertical asymptote should be at 3. So I'm going to put the vertical asymptote there. It also has a horizontal asymptote. The degree of the top is less than the bottom. Horizontal asymptote is 0. And then I'm going to plot a point. So like if I plug in a 4, I get 1. So I know it's going to do this here. And say if I plug in a 0, I get negative 1/3, so something like this. So I can see that that's the graph. You're also able to graph it in Y1. So now if I follow the graph, here's my 3. I go towards 3 from the right, and because my graph is going up here, that's the other way that I can see. So looking at the picture, the limit as x approaches 3 from the right of f of x, we get infinity from the picture. Okay? So the trend of the graph. And if you have your calculator, obviously you're able to graph it on the calculator. Okay? But hopefully you can graph this without it. So what makes only the denominator 0 represents a vertical asymptote. Okay, analytically. So how am I going to do this by hand? So I'm going to tell you, here's how I would work this. I'm going to go ahead and plug this in. I'm going to plug the 3 into the bottom. But I'm not going to put 0, I'm going to put what type of 0? Because the bottom is going to 0. So I'm going to put that it's 1 over a positive 0. Right? Because it's approaching 0, but it's approaching 0 with positive numbers, not negative numbers. 0.1, 0.01, 0.001. And thus, I know that 1 over a very, very small positive number has to approach infinity. And that's the thought process that I use. That's how I'm doing it analytically. Okay? We'll do another one in a second. I'll show you. but that's how I would work that out. So I do my substitution, but I don't just put zero, I put what type of zero. How do I know it's a positive zero? Because these numbers are a little bit bigger than 3. So a little bit bigger than 3 minus 3 is going to go to 0, but a positive 0. So if we just assume this, if k is a positive number, and I have k over something that goes to negative 0, then that's going to go to negative infinity. If I have k over something that goes to positive 0, then that's going to go to positive infinity. And k, again, I'm just using as a constant. And this is how I would work the problem in that method without a calculator. Okay, all right, let's try another one. We'll call this one example 2. So let me ask you this. If I took the plus off though, guys, real quick, I take the plus off and I just say the limit as x approaches 3, what's the answer? Why is it does not exist?
It's approaching 2 seconds.
Yeah, but even if both were going up, since it's not a specific y, it still does not exist. So infinity doesn't count. Okay? But you're right, it is going in 2 different directions there. Okay. So let's try another one. We'll call this one example 2. And say the limit, we're going to do the limit as x approaches negative 2 from the left of 1 over x squared minus 4. It's not always going to be 1 over, I'm just starting off. So let's try these. And let's do this. So try it with your table. All right, then try it with a graph, if you can look at the graph. And then try it with see if you can figure it out. How could we figure it out? Without any of those. Okay. I'll probably do like 4 entries on my table. Negative 2.1, negative 2.01. You can graph it on your calculator to have a look at the graph. Now, once you got one answer, of course, you don't have to work the problem 3 times. The only reason we're working it 3 times to show you all 3, which should give you the same answer. So the question is, how do I do this one analytically? I know that the bottom goes to a 0. The question is, does it go to a positive 0 or a negative 0? And I know which one it goes to. I'll show you. All right, so let's do this. Ivan, if you can give us the table, and Eli, if you can give us the graph, and then Brewski will talk about how you think we can do it analytically, okay? And we'll just double check your table. All right. So Ivan, are you ready with the table?
Yeah.
Okay, give us your table, please. 2.439?
Yeah.
Okay,
Then it was 24.938.
okay.
Then it was 249.94. Then it was.
And sorry, real quick, I think it'll tell you to round to 2 decimals when you type it in on the WebAssign, okay? And then what was the last one?
2,499.9.
Okay. So obviously, we can see the trend. The numbers are getting larger and larger, so we can see that the y's are approaching what? Infinity. So technically, you're done. That's your answer. Now, everything that should happen here should coincide with that. Now, I'll show you how I graph this by hand. We'll see if you agree. I can see that the asymptotes are -2 and 2 because I know there's 2 numbers that make only the bottom 0. I didn't know that the horizontal asymptote is 0 because anytime the degree of the top is less than the bottom, the horizontal asymptote is y equals 0. And I went ahead and plugged in a 0. And when I plug in a 0, I get a negative output. So I know the graph is here like this in that area. And then typically what happens is your graph is diagonal in a diagonal space. So when you're graphing rational functions, it's typically in a diagonal space. So does that look like what you had on your calculator? So now, if we look at the graph, so we approach -2 from which side, Eli? The left, and it's going to positive infinity. Had we asked the same question and from the right, my answer has to be what? If I said -2 with a plus, it would give what? Negative infinity. Okay. So same answer. So we still got infinity. So now the question is, how can we do this analytically? So the key is, I know I want to plug in a number. What's the number left of -2? What's a close number left of -2? Yeah, that's a good one to think about. So here's what I'm thinking about. If I plug in a -2.1, I'm going to do that squared minus 4. So I'm thinking, this answer here, is it going to be bigger than 4 or less than 4 if I do 2.1 squared or -2.1 squared? Bless you. Just a little bit bigger than 4. Thus, we're going to get 1 over what type of 0? A positive 0 or a negative 0? And therefore, by that instruction, we know that it goes to infinity. Because 1 over a number that gets close, that's very close to a positive 0 is going to go to positive infinity. And that's the thinking that I took there. Because that's just a little bit bigger than 4. So it's got to say, take some thinking there, okay? But you're really using this method here, is what you're really doing, okay? And so again, if I had the same question, the limit, let's just say we had the limit as x approaches 2 from the left of 1 over x squared minus 4. I don't really think I need to do a table again. What's going to be the fastest method right now? Not -2, 2. Limit as x approaches 2 from the left. What's the fastest method?
The graph.
Yeah, you got the graph. What? Just look at the picture. Here's 2. I'm approaching from the left. What are my y's going to? Negative infinity. Now, look at it analytically. What's the number left of 2? So this is 2 from the left, not -2. What's the number left of 2? So if I do 1.9 squared minus 4, my question is, what type of 0 do I have on the bottom? A positive 0 or a negative 0? You have a negative because this is a little smaller than 2. Squaring it's going to be a little bit smaller than 4. 4 minus 4 you got a -0, and that's not even 50. And this is what you'll be dealing with in the first part of 1.5. So you can go ahead and get started in 1.5 for now, and we'll finish this lesson tomorrow. That's it.